Okay, so this is, I told you before already that Wi-Fi is widely available on urban areas. That's what that picture on the left shows. Well, your right shows that you can see that's the availability of Wi-Fi access points on roads in the city of Porto. And you see that most of it is way above 10 available access points in each 20 by 20 centimeter, not centimeters, meter cells. So Wi-Fi is there and we should be able to use it, but it's not easy, and everybody knows it's not easy to connect to Wi-Fi and then to roam around using Wi-Fi access points. So the idea here is how could we use this access point to take away from the car sensor data, sensor stream data. This could be videos, this could be LiDAR, but this could also be smaller data, just taking it off using Wi-Fi. And the idea here is that multipath transport. So not trying to do this at the lowest layer, but trying to use the transport layer, trying to connect to more than one network and use this multiple connectivity to then send more over the ones that have a better connection and send less, or then shift traffic around according to the quality of the connections. And so that's what multipath is for. So this was one of our proposals. We are still evaluating it. So the idea is that we have application on top. Those squares are the frames that you would have for a video or the point clouds for a LiDAR. Underneath you have this multi-access RTP, which is built on top of the RTP, the real-time protocol. It's a very old protocol designed for multimedia transmission, runs on top of UDP, and above all, it does not have any kind of reliability. So it does not delay or retransmit by itself. The key part of this protocol is then how do you shift the data among the multiple connections that you have. Okay, so that is the scheduler. As we already had seen for Wi-Fi, we are going to rely on a context-aware scheduler. This means it's using your current Wi-Fi, your current position, the speed, the heading, eventually to choose which other kinds of data it's going to use to decide where to send packets to. And of course, we are using here the network performance monitor. You remember the database that I showed in the previous presentation? It's the same. So you can be collecting this all the time and then uploading it to a centralized base station so they can keep track, not the base station, a network performance monitor station that in the 5G networks is somewhere on the NWDAF or somewhere there. We are not concerned here about how the exact implementation of this station is, but we do have, it's a georeference station, and it contains data like round trip times, number of bits, the jitter. It can also contain throughput data, bit error rate. So it can contain different types of data collected by different types of devices, georeference. So for each position that you are in, you have a set of data measurements from previous times in your surroundings, and you can use that to make your decision. So the key thing, or one of the main reasons why we decided to use the RTP is that you also have RTCP and the real-time transport, the real-time control protocol. It's automatically, well, it by default collects measurements about the quality of your session. So also at the application layer. And with this metrics would be additional data that we can then also input in our network performance manager. So not only lower layer metrics like we were talking about before, but also this high session layer metrics. So this is was also sort of built. And then we have our experimental setup, which comes again from the vulnerable road user use case. We have a camera. It's sending data via some device, and then we have our multipath gateway on a Raspberry Pi. The reason we have this on a Raspberry Pi is that then we can implement different types of multipath schedulers, multipath protocols. Ours is not the only one. So we did implement ours. This is a very complex picture, but just in blue there, does this have a cursor? So here in blue, you have the data plane, and we would have our context data coming from outside in this orange and our positioning coming from the GPS. And then we have our scheduler, which is the smart part of this multipath. gateway. On the other side, we have a virtualized edge infrastructure. Of course, we need an endpoint for the multipath transport. Always need. You are building a multipath tunnel in any way, and you need a multipath receiver, and then you connect to the receiving service. We also implemented in another task at use the OpenMTP MPTCP router. It has an implementation also for the Raspberry Pi, so that it serves as a baseline for our comparison. And this is our setup. I will not be able to show you any results because we have not finished processing that, but I'm going to let Bernardo explain what he did. Before that, this is our experimental setup. Oh, I cannot. The cursor doesn't work. So we are doing this in the School of Engineering. We have an access point. We have a 5G base station that is, well, somewhere there. And then all the node.
And we are using several different schedulers, some more traditional and some more complex. And in the end, we compare them and see which one is best.
So now I'll let Bernardo, he's here, explain to you what he did.
For this part, we are using AnaAguiar2 to send a video format. And we are using several different schedulers, some more traditional and some more complex. And in the end, we compare them and see which one is best.